fiber cement boards is a revolutionary building material which came into existence in the early 90s, replacing asbestos fiber cement products. Asbestos is removed due to health reasons and product is reinvented with new technology. The asbestos fiber is replaced with wood pulp. The pulp provides the fiber that prevents cracking. Production begins with silica sand. The sand is fed into a hopper and then carried by a belt weigher conveying system. The sand particles are to be ground down into a fine powder. The conveyor takes the sand up to a revolving cylindrical grinder called a ball mill. It is so called because inside, steel balls tumble around to reduce the sand particles to smaller bits. Water is added to keep dust down and eliminate the need for an exhaust system. This also liquefies the sand, making it easier to pipe it into the plant during the various stages of process. The sand needs to be thickened substantially, so it is fed into a tank to drain out much of the moisture. The next ingredient is wood pulp, which gives the cement sheets bending strength. Without pulp, the fiber cement sheets will be brittle and crack easily. They add water and stir to soften and liquidify the pulp so that it can be easily pumped around the factory. The additives are mainly aluminium trihydrate and flocculant. These are added in correct proportion with the help of weigh hoppers fitted with load cell and a dosing system. They blend together cement, the liquefied sand and pulp additives, creating a fiber cement slurry. The fiber cement slurry is fed to rotating sieves, over which an endless felt moves at predetermined speed. Residual water is drained out through the mesh walls of the sieves, leaving a fiber cement film on the surface. The film transfers to the felt due to couching action. Then, through the felt, a vacuum mechanism sucks more moisture from the felt until it forms a semi-solid film, suitable to be wound on the forming roll. The film is built up continuously on the rotating forming roll until the desired thickness is achieved. The thickness of sheet is displayed by a laser thickness measuring system. A spray of high-pressure water cuts the sheets into desired dimensions widthwise and lengthwise. Cutting of sheets is done by a highly sophisticated water jet cutting system. A robotic suctioning head picks up the fiber cement sheets and transmits them to trolleys. The sheets are fragile at this point and need to be handled carefully. The flat sheet molds are used in between every sheet to keep the sheets intact, and the trolleys are passed through a heating chamber where the sheets are preheated for about 4 to 5 hours. The sheets are then sent to autoclaving through the auto trolley handling mechanism. The high-pressure steam enhances the chemical reaction between the ingredients. A high temperature of about 180 degrees Celsius is maintained inside the autoclave to impart proper curing and strength to the sheets. The sheets after autoclaving are separated from the steel template by a destacker. The templates are returned to the circuit. The sheets are put onto a sheet stacker. They are then stacked on pallets and are ready for dispatch. It is advised to store the product indoors as far as possible. This plant, with state-of-the-art technology supplied by Intra to United Mining Industries Saudi Arabia, is in production since November 2015, and their brand Unisem is well accepted in the Middle East market. This is indeed another feather in the cap for Intra Group.